Algebraically solve each system of equations and state the method you used. Graphically check your answer, which means to plug it into your graphing calculator. So in this one here, when I look at this, because y is already by itself, and it says y is equal to all this jazz right here, I'm going to use substitution because it's already set up for me. Substitution? Spelling, not my strong suit. So I'm going to plug that into y here, because if y is equal to all this, then I can replace that y with all of that. So 2x plus 1/2 x plus 5 equals 10. And now I'm just solving for x. So I'm going to combine like terms here. I'm changing, 2x into 4x over 2 so that I can combine like terms here and get 5x over 2 plus 5 equals 10. Then I'm subtracting 5 from both sides. So I got 5/2 x equals 5. And now I'm going to multiply both sides by 2 over 5 because that would cancel all this out and tells me that x is equal to 2. Don't forget, when we're solving systems, we need to find the x value and the y value. So when we look through this, if we have an x value of 2, I'm going to plug that back into one of my equations. This one looks easiest to solve for y. So in that one, 1/2 times 2 is 1. Plus 5 is 6. If the question's ever asking you to write it as a coordinate, write x and y value 2, 6. All right, second one here, I'm going to go ahead and use kind of two things. Really, it depends on how you learned it, right? Elimination is what I'm going to use, but to do elimination, I'm also going to use multiplication. Because if you see here, I have my y values over my y values, x over x, constant over constant, the equal sign. When all of this matches up, that's when I choose to use elimination. But elimination means to eliminate something. And to do that, we need to have the same coefficient. So what I'm going to do here on this one is I'm going to multiply this whole equation on the bottom here by 2. And so when I rewrite this, right, the top equation, 2y minus 3x equals 7, over my new equation on the bottom, it's negative 2y plus 4x equals negative 4. Now, in elimination, basically what I can do with these two equations is add them together. Because when I add them, I get 2y minus y, which gets rid of all of the y's. And so then I just do negative 3x plus 4x, which is x, 7 plus a negative 4, which is 3, and that gives me my x value. Same thing with the first one, though. Remember, if I'm solving for a system, I got to plug that back in to one of the equations. So I'm going to go ahead and use the top one because there's less, negatives to deal with, I guess. So 2i minus 3 times 3 equals 7. So I got 2y minus 9 equals 7. Add 9 to both sides to get 16. And so my y value ends up being 8. If you're asked to write it as a coordinate, you got 3, 8. Solving systems, baby.